Hello everyone, good morning, good evening, wherever you are. I'm Rahul here. Am I audible to you?
Yes, sir.
Okay, thank you so much and welcome to this very interesting course that we have launched, Data Analytics with Python and Machine Learning. Okay, first I will discuss a few things about this course and then I will take your questions, whatever you have. Okay. So request all of you to just mute yourself and unmute whenever you want to ask something or whenever you have a doubt. Okay. Thank you so much and welcome again. Right. So we are calling this course as Data Analytics with Python, and then we'll learn machine learning first without help of any cloud environment, and then we'll move on to the Azure cloud for doing machine learning activities. OK, and interestingly, there's a corresponding certification for that as well, which is called Azure DP100 certification. OK, and that's the only certification for data science and machine related stuff, unlike other aspects in Azure where we have a 900 series, which is for the basics or fundamentals kind of certification, and then some advanced stuff. OK, but anyhow, we'll discuss more about it later. So coming back to this course, data analytics with Python and machine learning, very interesting. OK, if you want to make a career out of the world of data analysis and machine learning aspect. OK, and of course you can treat this as some sort of a guiding window if you want to get into the world of something like artificial intelligence. And then let me also tell you how all these are related to each other. OK, but before that, there are a few questions which I have received on WhatsApp, OK, about why Python, isn't it? That's an interesting question. Why not using any other language? Well, we have a plethora of languages to choose from if you want to do something like machine learning. OK, I have seen many people using R language for doing that. I mean, for doing predictive data analysis and machine learning and all that. OK, Microsoft has come up with something called ML.NET, OK, for doing machine learning in .NET. But let me tell you, nothing beats Python, OK, for its simplicity, for its popularity, for its huge libraries which are available, OK, for doing machine learning kind of activities, right? So even though we can say we can do similar things in other languages, OK, even though we can say there are many competitions, but they're all far away from what industry prefers. OK, that's more important. Got it? What industry prefers. So learning an alternate is not a big deal, but what is the use of it if you're not going to use it, right? In your job profile or wherever you want to apply it practically or in realistic way, right? Python and to some extent R language will be used. That's it. I'm talking about data analysis and machine learning. OK, AI is a different beast altogether. As the course progresses, I'll tell you, OK, why other languages are also popular for accessing AI related stuff, and AI SDKs are available from so many cloud providers, including Microsoft, Azure and AWS and Google and all that stuff. OK, but I told you, right, that's a different beast altogether. And for that, we have different set of technology and different courses which are being offered from our side. OK, so I think some of you have already attended AI 900 webinars and courses from our side. And then there is an ongoing batch, I guess, of AI 102 by Suresh, I guess, right? So that is what these are ongoing things. So we are in a slightly different world. Yeah, you can say these are kind of multiverses which are connected. Yes. And what is the connection between all these things? AI and ML, right? These are the connectivity aspects of these things. So this course will begin with a quick overview, or you can say kind of a review or revision of Python language. And to be very specific, we are going to use an environment where we are going to use that environment throughout our journey of learning this data analysis and machine learning aspect. OK, so the major environment where we'll be learning and doing all these things will be through something called Jupyter Notebook. Okay, so when I do a Python language overview, rather, I'm not sure whether you were informed or not, but I'm telling you now, Python language knowledge is the prerequisite for attending this course. Okay, you should be aware of Python language. And if you are not aware, or if you are not yet comfortable in Python, don't worry. We will be giving you access to my earlier recordings of Python language. Okay, I used to do Python sessions. Yeah, stopped from past 6 months because of some pressing issues. Okay, but the videos from earlier batches are already there. So I'll tell you about the batch schedule. Okay, when are we gonna resume our actual classes after today? I'll tell you all that schedule. So before you come back to the next class, okay, I highly suggest you to go through those videos. Okay, become strong in Python fundamentals. That's important. Okay, because as we proceed further, right, and we are gonna do or use lots of interesting aspects of Python, lots of interesting functions of Python. So if you are not aware of Python, you'll not be very comfortable. Okay, so that is why I'm putting that as the prerequisite. And then the real journey will start with the data analysis libraries and machine learning. Okay, so before that, get accustomed to Python, and anyhow, installing and working with Jupyter Notebook is something that I will be taking care of. Okay, so that's basically the aspect. Okay, so let's continue our journey. So what is Python, right? In case if you're new to Python, or even if you're aware of Python, this will be sort of a revision for you. So what is Python? Well, it's a dynamic interpreted high level programming language for general purpose programming. Remember, programming languages are sometimes specialized, okay, and they are used for specific purpose. Like, for example, we talk about something called system programming and application programming, isn't it? So system programming mostly deals with something like low level programming. Like, for example, you want to write say device drivers, right? When you buy, let's say, a printer, or when you buy something like a scanner, isn't it? They'll give you some software to make that hardware work, isn't it? To make the hardware work, we need software. So that is what basically we call it as device driver. OK, or you want to, let's say, write some operating system utility. You want to interact with the operating system, right? You want to call certain libraries. So that is what basically is what we call it as kind of system programming. OK, interfacing with the hardware or interact with the OS. So that's system programming. There's another category of programming which we call it as application programming. OK, so this is where major development happens. OK, I'm not saying system programming is not so popular, but majority of the developers in the world out there, OK, most of the careers out there in software development happens in application programming. Now, this area is where you do application development for day-to-day applications that you use. So whether they are CLI applications that you can run at your command prompt or terminal, okay, or we can have something like uh, a GUI application which is running on your desktop, right? Or maybe an application which is running at the server side and clients are interacting with it, maybe from the mobile device or maybe from a browser, right? Which is very popular way of interacting with server side applications. Or maybe there is some application installed on your computer, maybe or your device, and then it interacts with something at the server side, right? For example, a web server where a web application is deployed. So obviously, when I say web application, naturally it is some piece of code which is running on the web server side. So when I say piece of code, obviously development is involved. Naturally, somebody has done some coding there, isn't it? Like, for example, you can do web application development in Python, or you can do using .NET. So that is where ASP.NET gets involved, right? Or you can do it in Java, where the basic libraries would be something like servlets and JSPs. But then typically we use certain frameworks, like, for example, struts or Spring MVC, right? Or Spring Boot, isn't it? These are basically frameworks which are built on certain libraries, which assist us in doing complex application development with ease. OK, so these kind of languages are called general purpose languages. OK, for example, C# for the .NET platform, or Java or Python. We put all this in what we call it as general purpose programming languages. Okay, so Python also falls in that category. So it's dynamic. Okay, very interesting. Why it's called dynamic? Because you don't have to declare pre-declare rather data variables of any specific data types before using the variables. Like for example, if you're coming from C family, right? Unless you declare a variable. When I say C family, that includes all the languages under the hood. Okay, like C, C++, Java, C#. Okay, unless a variable is declared, you cannot use it. Okay, and more specifically, the variable has to be of a specific type. Okay, and then it can hold value of that type only. For example, if you declare a variable named A of type int, now throughout its lifetime, that variable A can hold only integer type of value. Okay, it cannot hold any other type of value. Now these are called as static data typed languages. Okay, and most of these static languages obviously are, for the obvious reason, they are compiled languages. Okay, compiler knows what kind of value can be held in what variable. But there's another category of languages called interpreted languages, where you directly provide the source code for execution, isn't it? So, and interpreted languages are dynamic by nature. Okay, not just Python. You take any interpreted language. For example, you take JavaScript or PHP or Perl or Ruby. Okay, they're all dynamic. That means you don't have to pre-declare variables of a particular data type. Okay, a variable, when it comes into existence, now it is holding a numeric value. After some time, it can hold some other kind of value. For example, it can hold a string or a boolean or any other kind of valid object in that language. Okay, so we call such languages as dynamic languages. So Python being interpreted by nature, obviously it is dynamic. And then very interestingly, okay, they have, as the language is progressing, they have added an interesting feature where you can compile Python code. Okay, not many people are aware of it, or even if they are aware of it, they do not explicitly use this facility. But whoever is aware of this facility will actually know the benefit of it. Okay, so Python code can be compiled. Okay, and the code that we get from Python is kind of bytecode. That means it's an intermediate language, neither source code nor machine code. So we call it as intermediate language. And just like Java environment, we call it as something like bytecode, where the compiled code basically already consists of things which Python can quickly execute. Okay, because the source code, what we say, parsing and understanding it is already done. The only step remaining is simply execute that code. So Python code can be compiled as well, even though that aspect is not very popular. OK, and not many use cases are there for that. And Python is not majorly used in that front. OK, and interestingly, Python runtime also will compile the code that you use again and again. For example, whenever you create something like a module in Python, it is automatically pre-compiled. OK, unless you modify that code. And if you modify, obviously it will be recompiled. So that happens internally behind the scenes. So it's a high level programming language. Obviously, we all know what are high level, right? These are the languages that we all understand, but your computer cannot understand. So it needs to be translated. And you know, there are two types of translators, compilers and interpreters. So Python falls under interpreted language. So what happens in interpreted language? The source code is understood by a process called parsing, and then it is converted into native code, and the underlying hardware will execute that native code. OK, so that process is called interpreter. So we need to have Python interpreter in order to execute our Python code. Now, interestingly, where is Python interpreter? Well, if you're coming from Unix or Linux background, you know that Python is already there on your machine. OK, it is bundled along with your operating system, right? So Unix and Linux distributions have Python bundled along with them. And if it is any other operating system, for example, Windows, then obviously you need to install Python, OK, for your flavor of Windows based on 32-bit, 62-bit, 64-bit. OK, 32-bit is mostly outdated now. OK, but there are still certain environments where 32-bit is preferred, but not for general purpose or real-time deployments and all that. OK, so you need to install the appropriate version of Python. OK, don't worry, in case you're using Windows, I'll tell you from where to download and how to install Python, which version is preferred. OK, because if you go to the Python download site, OK, Of course, you'll get at the top, you'll get the link of the latest and greatest version, stable version available for download and install. And what is the significance of other versions and how to decide which version to use. OK, so we'll discuss more about that later. So yeah, Python should be there in your environment. And then we have a Python package manager, which goes by name pip. OK. So using pip, you'll install all other dependencies, whichever you need for learning and developing and deploying and running Python applications. OK, so for example, the popular Python libraries like NumPy or Pandas or scikit-learn, whatever, right? Whatever is not bundled with the Python core library, that is something that you need to explicitly install. And how to install it? Using the Python package indexer, which goes by name pip. OK, like for example, Java people use something like Maven or Gradle, isn't it? And .NET people use something called NuGet, isn't it, for dependency management. Similarly, majorly Python people use something called pip, OK, for doing dependency management. Is there an alternate? Yeah, there's an alternate, OK, which goes by name Conda, CONDA, OK, Conda. Very interesting name. That can also be used for dependency management. OK, but then the Conda repository has very limited set of libraries when compared to pip, because Conda is specifically for doing data analysis and machine learning and all that. So that's why its repository is limited. And something which is not found in Conda, people usually install it using pip. OK, but pip is universal. So these are the dependency management aspects of Python. So coming back, it's a dynamic language. OK, it features a dynamic type system. You all know what I mean by dynamic type system. A variable need not be pre-declared before using it. OK, so whenever you want to use a variable for the first time, at that moment it comes into existence and it is available till the scope in which it is declared. So if you have declared it, I mean, if you have used it for the first time in a function, it will be visible till the end of the function. Or if you have declared it as a global variable, it will be visible in your entire Python script. OK, that's an interesting term that I'm using called Python script. So the piece of code that you write in Python and save in a file, which goes by the extension called .py, right? We don't call it as a Python file, or you don't call it as a Python program or Python application. OK, we call it as a Python script. So when a variable is declared at the top level in a script, it falls under the category called global variable. OK, and it will be visible in the entire script or till the end of the script, like that. OK, and then of course, as a modern language, it is also object oriented by nature. OK, so you can do programming in Python in the traditional style, which goes by name procedural programming, or you can also do object oriented programming in Python. OK, when I say procedural, it is same like C style of programming or Pascal style, where we don't talk about objects. OK, there's no object involved. You simply write programming in functions and then you call the function as and when you need them. OK, that's procedural style. Whereas in object oriented style, we talk about certain data to hold the state and the behavior which will access the data or modify the data. The behavior is implemented in the form of methods. So these variables and methods put together, the place where we put them together is called as a class. And then when you create instance of the class, we basically call that instance as objects. So you will create objects as and when needed, and you will interact with those objects, or you will make those objects talk to each other as and when needed. So this style of approach is called as object-oriented programming. So what is Python? Well, it is an object-oriented language. OK, but you can also do programming using procedural style. What does that mean? It means it's not necessary to write a class in order to do programming in Python. OK, but you know, sometimes if my script is bigger, if it is becoming a bit complex, I want to put together my data and the behavior. OK, I want to associate them together, then you'll end up doing object-oriented programming. So for example, in an employee management application, right, employee would be represented as an object. Got it? Otherwise, there's no data structure to represent it, isn't it? So we'll represent it as an object. If it is a banking application, the account of a bank will be represented as an object. Okay, so if it is a library management application, a book in a library will be represented as an object. In procedural style, there is no such term. Okay, so how do you put together certain values which are related to each other? How do you put them together? Well, it depends on the facilities of the language. So if you take C language, you'll end up writing something like a structure. Okay, or if it is Pascal, you'll end up writing something called a record, isn't it? So different languages have different provisions to put together the related variables. Okay, so in object-oriented style, a class is a place where you'll put all your related stuff together. So that is why we say it is an object-oriented approach. There are certain principles of programming which a language should support, and if it supports them, it is object-oriented by nature. Okay, for example, C++, Java, C#, Objective-C, okay, Smalltalk. They all fall under that category called object-oriented language. So Python also falls in that category. And interestingly, let me tell you, in Python, everything is an object, whether you like it or not. Okay, so what does that mean? For example, if you want to represent a number in Python, that is in the runtime, it is actually represented as an object. You got it? So if you want to represent, let's say, a string, it is represented as an object. If you want to work with a list, that is represented as an object. So whatever you want to work with is represented as an object, whether you like it or not. So if you want to basically, okay, create your own type, that also is represented as an object. Okay, everything basically is an object. Okay, so it's a object-oriented language, and of course, interestingly, Python source code is highly portable. That means when you write a piece of Python code, right, unless you are dependent on certain libraries from the underlying operating system, okay, you will be able to easily port the code from one platform to other platform. That means when I write some piece of code in Python, right, I'm not writing it for, let's say, Windows or Linux or Mac OS or any other platform where Python is supported. Got it? So what do you mean by any other platform? For example, let's say Raspberry Pi, right? It has its own operating system called Raspbian. Of course, it is based on Debian. That means it is some flavor of Linux only, right? But the operating system goes by name Raspbian. So we are not confined to any particular type of operating system or platform. So mostly it is highly portable code. OK, unless you're dependent on certain libraries from the underlying operating system. For example, if you want to interact with underlying Windows operating system and get the list of users on that system, then obviously you have to become system specific, isn't it? Now, the way you interact with Windows will not be the way how you interact with Linux. Correct? So these are the places where the code will not be portable. Otherwise, okay, unless you are using such libraries, the code is more or less portable. Okay, but then, if you look at the features of Python language, we do not highlight this aspect very much. Okay, but yeah, it has been like this from day one. It is highly portable. So wherever Python interpreter is available, yes, you can run your Python code, and whatever dependencies are needed, you need to install them based on the environment. So if you are using Conda environment, you can install it using Conda. If you are not using Conda, if you are using regular Python, okay, for managing dependencies, then you can use pip and install dependencies, and your application will be able to work. Okay. So there's a question in the chat window. What is programming versus script? Well, there's a slight difference in that terminology. It's not programming versus script. The question should have been program versus script. OK, because whether it is program or whether it is script that you're writing, you'll have to end up using a programming language. OK, so basically, when you talk about program, it is basically, a piece of code which has been written to achieve a specific task. OK, obviously that piece of code needs to be translated and executed and all that stuff. OK, but when you talk about scripting language, OK, for which we use, we end up writing a script using it. So script basically is like a small program. OK, so which is used for doing a specific task at a time. For example, create a user. That's a very small task, right? So a small task which has been created to a specific purpose. That is what basically is scripting. OK, is very specific and it is very pinpoint. So that's the concept of what do you mean by script. OK, for example, a piece of code to quickly create a network. So that's basically called as a script. So language for doing that is called scripting language. For example, PowerShell from Microsoft has its own syntax for doing something called commandlets, right? So it's a scripting language. So if you take Unix and Linux, we have something called shell scripting. So what is shell scripting? Certain syntax which has been provided to write some piece of code, which quickly allows you to run in your operating system without bothering about installing the runtime for any programming language. So it's basically shell script because it can run in a shell. OK, and of course, shell scripting is specific to a particular shell. OK, so for example, we have bash shell. So it recognizes the bash scripting. OK, so if you have something like fish shell installed, then it has its own slightly different way of doing scripting, slightly different, almost same, but slightly different. So scripting environments are specific to a particular scripting environment. So Python also falls in the same category. It's a scripting language. That means it will have its own environment. It has its own syntax. So that environment is something which is either already there or something that you need to install. OK, by the way, a general question for you guys. Santosh is asking, are you sharing your screen? Are you guys able to see my screen?
Yes, sir.
OK, thank you. Well, I'm referring to the slide which is there on the screen. So obviously you will not see slides changing. OK, hope that helps. Right. So I was talking about Python being highly portable. OK, so let's continue from there. What else you need to know about Python? Why should you learn Python? Well, I told you, right? It is not platform specific. You can run Python code wherever Python interpreters are available. OK, and then yeah, Python has a simple and easy to understand syntax. How do you know that? Well, it all depends on your learning other languages and your ability to pick up and do things, right? For example, what you do in other languages using n lines of code, you can do in Python using less than n lines of code. So obviously it implies the language is concise, OK, and precise. It is easy to learn because the syntax is easy to pick up. OK, it's not a very cryptic syntax, not very restricted syntax like C family. For example, you don't have to terminate your statements with semicolon. OK, whenever you want to write a new statement, you just have to go to the next line. That's it. You don't have to put a semicolon, not needed. And then you can represent strings in either single quote or double quote. OK, you don't have to pre-declare variables. So these are the things, I mean, little bit things. OK, I mean, there are so many things in Python, OK, which makes it very easy. But I'm just pinpointing you certain aspects which we all can understand at this stage. OK, so it has a simple and easy to understand syntax. Obviously, it allows developers to write lines, I mean, code with fewer lines of code. OK, like for example, if you want to, let's say, construct a list and you need to apply some logic, then obviously you need to write a for loop and the logic embedded in the for loop. So rather than doing that, you can use a feature called list comprehension and reduce the number of lines that you use in order to construct a list. Right. So this is basically concise way of doing coding. So list comprehension or enumeration, right? Or trying to work with the data structures with lots of built-in functionality. So these are the things which allows us to write code in Python with fewer lines of code. OK, that is something which is very interesting. It's an interpreted language. So as soon as your code is ready, you can go ahead and execute it. There is no complex compile or build process involved. OK, so if you want to quickly show something, basically we call it as if you want to do a pilot or if you want to do a prototype, that means you want to quickly showcase some feature or certain capability, right? If you need to have a quick turnaround for that. So in such case, obviously, This is where basically we talk about, okay, quick turnaround. So scripting languages are very good for that purpose. Okay. Of course, over a period of time in the long run, whether your customers want to stick to Python or not, if they have to decide, if they are the decision makers, okay, they will do that. But if you want to suggest, then obviously Python can be one such language. Okay. And obviously Python runtime is not very heavyweight. Okay. I mean, if you look at the RAM and CPU utilization of Python versus other languages, so Python footprint is much less when compared to other languages. Okay, what about speed? Yeah, obviously it's not good to compare apples with oranges, isn't it? You can't compare the performance of C and C++ at one end. Okay, something like Java and .NET at one end with Python at the other end. You can't do that because they are compiled environments, right? They are compiled languages, whereas Python is not. Okay, but that's not the only criteria. Nowadays, system CPUs are very fast. Okay, we have lots of RAM available at your disposal. So the things that were restrictive or things which were luxury, let's say a few years back, are assumed to be taken for granted. Okay, and of course, with every version of Python, okay, the performance is going on increasing and increasing. So for example, if you take the current stable version of Python which is being used, that is Python 3.11. Of course, I know 3.12 is also there, but if you look at 3.11, right, which is slowly getting accepted in the industry. Okay, 3.11 is much faster in performance when compared to the earlier versions of Python. Okay, much faster because they have done some optimization, certain enhancements in the runtime, which increases the speed of Python execution. Okay, so day is not far when maybe Python performance will be at par when compared to competing platforms like Java and .NET. Okay, in such case, yes, then we can say we can compare apple with apples and say is Python performance same as that of, let's say, Java or .NET. Okay, but let me tell you, even Java and .NET cannot match the performance as that of C and C++. Because those language runtimes are obviously written for executing native code, right? I mean, when you compile C or C++ code, what you get is executable, native executable, which is directly understood by the underlying hardware, right? C compiler for Windows will generate the Windows executable, whereas C compiler for Linux will generate the Linux executable, right? And that is nothing left to translate anything further. Directly, they have to be loaded in the RAM as part of process and then executed. So nothing can match their speed, of course, unless you do low level programming or assembly programming. Otherwise, okay, compiled code is considered to be fastest. Okay, but Python is not specifically for that purpose. Okay, sometimes you need to decide what is more appropriate rather than performance. Okay, like for example, if you have some fever and cough, you'll not go to a cardiologist, right? Isn't it? Similarly, if you want to do some general purpose programming, C and C++ are not the solution for all your issues or for all your requirements. Sometimes a general physician will also get the job done, right? So Python is like general physician. Got it. Whereas C and C++ are specialists, like for example, cardiologists or neurologists, they are specialists, right? Similarly, C and C++ are specialized languages for doing system programming. Like for example, if you look at the way people write operating systems or the way people write device drivers, so that is where C and C++ will get involved. Okay. And let me tell you, the days of C and C++ are numbered, by the way. Not necessary that everything has to be done in C and C++. Okay, so in many Unix and Linux distributions, certain operating system utilities are written in Python. That is why Python is bundled along with the operating system. You got it? So for example, if you look at any Linux distribution, you'll have Python already bundled in it. Why? Because there are certain utilities bundled in the operating system which are dependent on Python. You got it? Okay. And yeah, many applications are written in Python. For example, a few years back, I used to use a very popular and very fast editor called Sublime Text. Okay. Has anyone heard of it? Have you used that editor, by the way, guys? Sublime Text. Have you used it? Anyone? Feel free to unmute and talk. Let's make this session interactive. No one used Sublime Text?
No.
Yeah, I used to.
Okay, good. So what is that feature that you liked about that editor?
It's more like easy, fast.
Fast, right? That's important, isn't it? See, the moment you start or you launch the editor, right? It simply comes up on the screen and you can get the job doing, right? You don't have to wait for a few seconds for it to launch and then load your project or workspace in that and start working. So it's considered to be very fast editor. By the way, it's just an editor, right? So if you want to simply do some quick dirty programming, these editors are very handy. I still use it, but not as regular as we use something like Visual Studio Code or say something like Jupyter Notebooks, right? So they take some time to launch. Like Visual Studio Code, definitely not as fast as Sublime Text, but it takes some time to launch. And then Jupyter Notebook, yeah, obviously you need to start the Jupyter server and then open the notebook and then do coding. It all depends on what environment you prefer for doing coding, isn't it? Yeah. So what is important sometimes is convenience. That matters a lot. So yeah, there are in between I'll be taking questions from the chat. OK, so there's a question called what is procedural? Well, procedural is a style of programming where you concentrate on writing and invoking functions. So whatever you want to do repeatedly, you will write that piece of code in a function, or in other languages, you call it as a procedure. And then you will invoke it wherever you need to enhance that functionality. For example, if I want to, let's say, move a window. So there's a built-in function called moving a window. I will call that function. Wherever I want to move a window, I will call that function. OK, so that is procedural style. But that function will act on what data? It doesn't know that. So it has to be provided with that data, obviously through parameters. OK, now that is the approach in procedural style. Whereas in object-oriented style, suppose you represent window as an object, right? And you want to move a window. You just have to tell, I want to move a window. OK, you don't have to tell which window. It is already known which window you want to move. You don't have to give any parameters. I mean about window, because it is already aware of those values. You just have to provide parameters for the new location of the window for moving. OK, so in object-oriented style, we do not separate data and functionality, whereas in procedural style, they are separate. So the best example I can take is C language. OK, so for representing data, we write structures, and for implementing behavior, we write functions. So structure and functions are separate. You cannot put them or club them together. OK, whereas in object-oriented languages, they are put together as one single unit. OK, and that unit is basically a class. So class has the properties and behavior. Both are put together. That is what is object-oriented style. OK, Pavni, hope that is clear to you. Right, and that is why we said Python can be written in procedural as well as object-oriented style. OK, that's basically the concept. So let's proceed. So we can use Python for general purpose programming. For example, a web application, OK, using Python languages like Django, or I mean Python frameworks like Django or Flask. OK, so we can use Python for scripting, for doing small things. OK, for example, quickly create a network. OK, or let's say I want to read data from a file and send an email. OK, so this is what basically we call it as scripts. So what about program then? If script is a small program, OK, if I have to distinguish between them, program can be very generic. OK, it's a very generic term, and program can be huge in size. OK, whereas, for example, your text editor, OK, or your application like MS Word or Paintbrush or a web server, OK, that can be called as a program, a huge piece of code, whereas script is something which is very small, written for a specific purpose. For example, read data from file and send an email, or create a report and save that report, or email that report. OK, or if you want to quickly, let's say, create a network with certain subnets, and you're providing all the information in the form of parameters to that script. So that's basically called as a script. A small task is called script. OK, so whenever you want to repeatedly do some task, we write a script for that and execute that script whenever you want to do the task. So this is called as scripting, and usually we call that as automation. Okay, for example, sending a report. Okay, I don't want to do that manually, or creating a network. I don't want to, okay, write the same code again and again. I just write it, and that's called automation. For example, okay, just to make you understand, if you are aware of cloud environment, right? So whenever you want to create a virtual machine, got it? Whenever you want to create a virtual machine, so your cloud service provider, okay, execute some script at the back end, and using that script, the virtual machine will get created. So what they have done, they have automated the process of creating a virtual machine. Got it? That's called automation. Okay, something which is written once, okay, for as generalized code, and it can be provided with some parameters and reused again and again. That's basically called as automation. Okay, and when things are automated, obviously we can achieve things faster, we are saving time, and we become more efficient. Okay, that's the concept. So as a general purpose programming language, we can use it for writing command line applications or GUI applications that can run on our desktop, or we can use it for automation. Okay, or you can use it for web development and API development. Okay, that's also important. Sometimes you need to write not only some piece of code, but also expose that piece of code through an API, right? So yes, Python can be used for exposing APIs as well. Django and Flask can be used for doing that. But then there is another popular Python library which is very popular for that. OK, that's called Fast API. So that is used for writing APIs and exposing APIs in Python in a very rapid way. And then coming to the bulk utilization of Python apart from scripting in the industry. OK, so that's basically the field of data, right? So the field of something called wherever you use data, okay, and analyze the data, take certain decisions based on the data, right? And you make machines intelligent by making it do tasks which we consider as smart. Okay, now that is what is called artificial intelligence, AI, the buzzword nowadays, isn't it? Everybody is nowadays aware of AI, even though you are in no way related to computer field, still people have heard that term nowadays, isn't it? Artificial intelligence. So in one line, if we have to tell what is artificial intelligence, basically you are making machines carry out tasks in a way we consider that as smart. Okay, so are people using artificial intelligence without knowing that it is artificial intelligence? Yes, they are. For example, if you take what example, let's say, okay, take something which everybody is using on a daily basis, a mobile phone, isn't it? A mobile phone has something like a photo gallery, right? And we add pictures to the photo gallery, right? Either you take the pictures through the camera or you add the pictures to the gallery, okay, through certain applications like WhatsApp or any other social messaging applications, right? Social media applications. You use add photos to the library. Once you add photos to library, right, and you tell to that gallery, this person is, let's say, Rahul, okay, or this person is Ravi, and then the next time you add a photo of Rahul to the photo gallery, right? It automatically recognizes that this is Rahul. You got that? Or if you tell that this is a dog and this is a cat, so next time you add a photo of dog, the photo gallery recognizes that this is a dog. Now that's basically artificial intelligence. Okay, so machines do tasks in a way we consider them as smart. Because okay, before machines were able to do smart things, we thought only humans were smart, isn't it? And to some extent primates, like basically monkey family, right? We thought only these species are smart. But then machines are also made smarter. How? You have to make them learn. Got it? And when they're learning, obviously they will become smart. So photo gallery automatically recognizing a dog or a cat or a person is obviously sort of intelligence, isn't it? So before this photo gallery in the mobile became intelligent, Facebook started using this feature long time back. Does anybody remember when you tag your friends in a photo, right? Facebook would automatically recognize them the next time you upload another photo having the same face. Has anybody experienced this? Right? Those who use Facebook a lot should be able to tell, isn't it? So long time back. It's not a feature that they started doing now, isn't it? They started having this feature many years back. So how was that possible? Obviously, it was possible through artificial intelligence, isn't it? So companies were using this from long time, from so many years. Let me tell you, artificial intelligence is not something which has picked up in last few years. OK, it was there from so many years in the world of computers. OK, but then it was not so widespreadly used. OK, the usage was not widespread, and two, there was no use case for a common man like you and me, right? And it became very useful. It became very popular when we started using this on our daily life. For example, people uploading images to Facebook and sharing them with your friends and colleagues, isn't it? So then you started realizing, yes, this is all happening because of artificial intelligence. OK, or we started having mobile phone in each and every hand, mostly. If you take developed countries, it's there in each and every hand. If you take developing countries, slowly the adoption is picking up, but whatever. So anybody who is using a smartphone, they're actually using sort of artificial intelligence. OK, for example, Apple introduced it long back in somewhere around 2010, 2011 with, if I'm not wrong, when they introduced Apple iPhone 4S, which was introduced, right? It came with a feature called Siri. Anybody remembers that? When was it introduced? It was introduced with iPhone 4S, isn't it? Now iPhone 15 is going on. Now remember, imagine when was 4S launched. Along with 4S, they introduced a feature called Siri. So you can ask Siri to do many things. OK, you can ask Siri to dial a number. You can ask Siri to save a contact. You can ask Siri to send a message. You can ask Siri to create an alarm for you, isn't it? So why all this is happening? That's nothing but artificial intelligence. Got it? So it was there from so many years. You were using it. OK, but the only thing is you may not be aware of it. OK, that's basically the concept. So artificial intelligence is a very generic environment. OK, so it can be used for identifying people. It can be used for identifying voice. It can be used for converting voice to text, that is called speech to text, or text to speech. It can be used for translation. And this is very important for people who travel across various countries, right? So if you land up in a country where you cannot speak the language of that country, like, so suddenly you end up in Spain where they talk Spanish and you only know maybe your own language plus, let's say, English. OK, and so obviously you'll have to take the help of a translator, right? So you cannot carry a person along with you wherever you go. So you have a smartphone with you. The smartphone, OK, can have an application which can convert speech of one language into another language, isn't it? You have many applications which can do that, right? Android has such capabilities. Even Apple has such capabilities, right? So they give an application which allows you to translate from one language to another, right? What is it? It's called as Translate, if I'm not wrong. I think iPhone has a built-in application called Translate, isn't it? Google has been doing this from so many years. You heard of Google Translate, right? Just go to Google engine, Google search page and say translate, and you'll get a two-column kind of a page where you'll type or say in one language and it will convert that into other language. So how is that happening? Obviously, that's artificial intelligence, isn't it? So it's a generic term. I mean, it's a term that has very vast use cases. OK, so it can be related to vision. It can be related to language. For example, many organizations use it for artificial intelligence for sentiment analysis, right? For example, somebody has written a comment on your post, maybe on Twitter or maybe on LinkedIn or maybe on Facebook, right? So somebody has written a comment. So what is that comment? Is it a positive comment or is it a negative comment? Is it a neutral comment? Right? So how do you know that? So obviously that is through something called sentiment analysis. So there are certain words which are considered to be positive. There are certain words which are considered to be negative. So a piece of code has been already trained to locate for such words. Okay. For example, you visit a restaurant. Okay. And then you give a review for that restaurant. So a person has to read the review and understand whether it is a positive or negative review, right? So a person is hired specifically for that purpose. So nowadays what's happening, rather than a person doing that, okay, the machine will do that for you. So obviously there is a piece of code which has been trained to understand certain words, and based on those words, it can understand the sentiment of that review. Is it a positive or is it a negative review? So what do restaurants do? They will only publish positive reviews on their website. Negative reviews they will simply ignore or discard. Isn't it? Everybody has become intelligent nowadays. So that's basically called sentiment analysis. OK, so all these are falling under the broad spectrum called artificial intelligence. So we have been training someone to understand, right? So artificial intelligence allows you to use those features. But how does the training happen? That's important, right? So training happens because of something called machine learning. OK, so are artificial intelligence and machine learning related? Definitely they are related. Remember, unless there is machine learning, there is no artificial intelligence. OK, so if I have to do a bit of whiteboarding and show you, got it. So there you go. If you say this is the field of artificial intelligence, OK, then obviously this is where machine learning fits into the picture. OK, so if this is the field of AI, so this is what is ML, the significance of ML. So unless there is machine learning, there cannot be AI. OK, so can I do AI without machine learning? Yes, because those who do machine learning will expose certain APIs, and somebody who wants to use that will simply call or use those APIs. That's it. For example, because some of you are already attending Azure AI course, right? So you'll be able to easily pick up that. So using Azure AI, what will you do? You'll end up using certain SDK for various languages, right? So you have Azure AI SDK for C#, for Java, for Python. We have SDK for so many languages. So what will you do? You will basically create objects and invoke functions which are part of that SDK. But do you know what do those functions internally do? They end up using certain ML models. OK, don't worry if you don't understand some terms. OK, so they use something called ML models, and because of which, OK, you are able to harness the concept called artificial intelligence on the cloud environment, or may not be in the cloud environment, whatever. OK, but majorly because all our lifestyle and all our infrastructure is nowadays cloud oriented. So the cloud service provider started providing these facilities where you can do machine learning in the cloud, or where you can apply artificial intelligence in the cloud. OK, so but let's get into all that later. Today's class is more about generic stuff. So you understood what is artificial intelligence, right? Machines will carry out tasks in a way we consider them smart. For example, recognize a person in the photo. OK, or convert speech from one language to other language, or understand the sentiment in a piece of text, isn't it? So we have lots of things associated with that. So we have vision API, there is speech API. They are very specific. OK, they cannot be generic. OK, remember some piece of code which has been written to recognize people and animal. You cannot use that piece of code to translate text from one language to another. So they are very, very specific terms. OK, so for example, if you have written some piece of code to make it recognize people in the photo, that cannot recognize a language and convert into other. OK, it has to be very, very specific. So it's a broader term. Artificial intelligence is very broader term. How things are happening? They're all happening because of the available data and making it learn through that data. OK, that is what is more important. So using data, OK, and finding some meaning out of that. Now that broad field is what we call it as data science. Got it? It's basically very very huge field, by the way. Okay, so when you talk about data science, it's all about using your knowledge of mathematics, your knowledge of statistics. Okay, so it has become kind of a new discipline. For example, if you look at the offerings from many universities and colleges, right? So for example, if you take the case of engineering, so there used to be streams like engineering in civil engineering or mechanical engineering or electronics, and then computer science, isn't it? So if you look at the stream called computer science, it is very generic. Okay. Now what they did, they started offering specialized streams in computer science. So you say computer science with, okay, more emphasis on cyber security, or computer science with more emphasis on artificial intelligence, or computer science with emphasis on data science. Okay, like that. So what is data science? It's a kind of a discipline now. Okay, kind of a, if you talk from the academic angle, it's obviously an academic discipline. So what do they do in that discipline? They teach you about how to use your maths and statistics knowledge and apply that knowledge on data to extract some meaningful information from the data. So obviously the prerequisite is that there is some data available. Okay. How is it available? We don't care. It may be there in database. Okay. Traditionally, people were using, I mean, organizations were using something like relational databases. Okay. Nowadays, if you look at the scale with which people are gathering data, and relational database will not be able to give you that good performance which is expected out of it. So organizations are migrating towards something called NoSQL data, right? Database. For example, MongoDB, or AWS has something called DynamoDB, or Azure provides you with something called Cosmos DB, right? So they're all NoSQL database. That means data is not stored in the traditional format of RDBMS. You no longer create tables and then organize data in the form of rows and columns, and then you make the tables related to each other using primary key, foreign key constraint. No, there's a huge amount of data that I'm gathering. Okay, and I just want to dump the data without bothering about the relation between the data across various tables or various collections. Okay, so that is what is NoSQL speciality. Okay, and there's a separate field dedicated for that. It's called big data. I'm sure most of you have heard about it, right? So big data is all about managing, I mean, working with huge amount of data from, various sources. Gather data from various sources and then manage such data. So for example, big data is that particular discipline. Okay. When you talk about data science, it's about using the available data for some meaningful purpose. Okay. So data science is quite huge, and you can divide data science into various aspects. Like for example, there is something called data analysis. So what do you do data analysis? When you have data given to you by compiling it from various sources, that is where the job of data engineer comes into picture, right? So there's a field called data engineering. So that's about working with data, purely working with data. Okay, understand how and where data is stored, understand how to extract that data and give it to someone who can use it for some purpose. Okay, or extract the data and convert into something which can be meaningful to others, right? That is what is basically ETL process, or nowadays we have something called ELT. Okay, whatever is the process. So that's basically the job of data engineer. So it's a vast field, right? So data science is about using that data to extract some meaningful information out of it. For example, data analysis is when you have data gathered, you analyze that data and present certain findings to help decision making. For example, okay, there's a factory which is, let's say, manufacturing ice cream. Okay, so what they will do if they want to manufacture certain ice cream, right? So what they will do, they will look at how much was the sale in the previous year, same quarter. Okay, like for example, the sale of ice cream depends on the season, isn't it? And season obviously can be usually recognized in the form of quarters. So first quarter, second quarter. So last year, second quarter, in this month, okay, what was the sale of our ice cream? right? And then which flavor was sold most. So that's the data which is available. I guess you're understanding that, right? That's the data which is available. So what will the ice cream manufacturing company do? They'll also basically look at that data and then decide, OK, now this is what we need to follow. This is what we need to manufacture. And these are the flavors that we need to concentrate on. So what are they doing? They are taking certain decisions by looking at the historical data. That means something which is already available. OK, that's basically the concept. That is what is data analysis. I'm just telling you things in short. OK, how do you do data analysis? Well, there are various tools for doing that. There are facilities in programming languages for doing that. OK, so we are going to see how to do data analysis in Python. That's one aspect. OK, that's basically the concept. Right. So you understood what is data analysis. Now, sometimes, people will not be able to understand data just by looking at it in the form of comma separated values or in the form of tabular data. No, people say, OK, can you make me understand that through a graph? OK, based on the purpose, you can create various graphs and charts, right? So there is something called bar graph. There's something called pie graph. You might have learned that in your school, and you might have done that practically also using the charts, isn't it? Remember your school days or college days where you used to buy graph sheets and then do the drawing on that graph sheet using pencil and scale and all other instruments, isn't it? So that is what in software field we call it as data visualization. OK, so understand the significance of data by showing it in a visual context. What do you mean by visual context? In the form of certain graphs and charts. OK, or sometimes you have to do what we call it as plotting. Got it? So the process of creating that is called plotting. So what they say, I have created a plot. Means what? I'm doing a bit of what visualization on the data. So there are ready-made tools available, or you can create those charts and plots programmatically as well. OK, because data is available in memory. So obviously I have to take that data and create my charts. So that's called data visualization. Is it part of data science? Yes, it is part of data science. OK, so data analysis is one part. Data visualization is one part. And then there is something called machine learning, right? So implement certain algorithm to automatically detect pattern in the given input. That's something which is very interesting, right? And a bit complex among all these aspects. So implement an algorithm. So basically when there is a data available, right? So there is an algorithm which can identify a pattern in that data. And by identifying a pattern, it can do certain predictions. OK, so basically you're making a machine. Machine means obviously ultimately some piece of code. You are writing some piece of code to recognize certain pattern in the data and making it predict certain output on the new data that you will provide to it. OK, for example, let's say there is some clinical data available of patients who visit a clinic, and then the clinic finds out whether they are diabetic or not. OK, so what data does the clinic gather? It gathers what is the age of the person, what is the weight of the person, what is the height of the person. From that, they can figure out what is the BMI of that person, right? The body mass index. They will find out, does the person have BP? OK, does the person have diabetics in the family, right? The family history. They will find out all that, and they will find out whether that person is diabetic or not by doing obviously certain tests on the blood, right? On the serum. So they do some, and then they figure out, OK, and then they'll make a note of all these observations. So this is the age. OK, this is the weight, this is the height, this is the BP of that person. There's a family history of the diabetics, and then what is the findings? Is the person diabetic or not? So there are let's say thousands of patient data is available. Now you make certain algorithm go through that data and recognize a pattern in that data, right? OK, if this is the age, if this is the BP, if there is a diabetic history in the family or not. Okay, this is the weight of the person, this is the height of the person. So you identify certain patterns in that and then look at the result. Okay, if this is that pattern, this person may be diabetic. If this is the pattern, this person may not be diabetic. So we basically end up having some function. Okay, listen carefully. We end up having some function which takes some input, and based on the previous observations, it will predict whether this person is diabetic or not. Okay, so what we have done, you have made a machine learn something by looking at the current data and then making some predictions. Remember, it is making some predictions. That predictions may or may not be accurate. Okay, if your algorithm is very good at recognizing patterns, then it might have better accuracy. If the algorithm is bad, it may have lower accuracy. But it is not 100, it not 100% need not be accurate. Okay, but it can recognize the patterns. That is what is more important. Okay, for example, if you look at, say, e-commerce websites, isn't it? When you buy some item, they suggest you some alternate item. For example, you buy a mobile, they will suggest you, those who bought the mobile also bought this charger, this cable, this protection case, this glass, and all those things, right? Protective glass on the mobile. They are able to suggest. These are called as recommendation engines. Okay. How do they do that? They do that because they have studied the historical data of somebody who has already bought that item in the past, and after buying that item, they have bought some other related item. Got it. So that's all about historical data. For example, if you're looking at, let's say, certain accessories for your pet, let's say you want to buy a leash. Okay. And then the e-commerce site will tell you those who bought the leash also bought a stick along with it. Okay. When you leash a dog, and then when you take the dog for walking, you might have seen some stick in their hands, in the owner's hand, right? Not the dog carrying the stick. The owner has the stick. So they say those who bought the leash also bought the stick along with it. Or if you're buying some pet food, okay, so if you take food A, they will suggest somebody who bought food A also bought food B along with it. Okay, so if you want to, let's say, buy certain biscuits for your dog, they will suggest there's a teeth cleaning bone also available for the dogs. So these are called as recommendation engines. So what do? They identify the patterns. There's nothing to predict here. Okay, they simply identify the patterns and then they tell you, okay, somebody who bought this may have also bought this. So that is how basically they'll increase the sales, isn't it? So that's basically the concept. Now, making a machine I just understand a pattern in the data, right? Looking at the historical data and make it do some predictions. Now that is what is called machine learning. The question is, how are they related to artificial intelligence? Well, if you make a machine recognize a pattern, you are making it learn something, isn't it? So that is how basically small children learn. If you remember, they are taught alphabets and then they are made to recognize the alphabets, isn't it? And then using those alphabets, we actually form words. And because you recognize the alphabets, you are able to identify which word is that, isn't it? So artificial intelligence is like that, slowly getting into the world of data, make the machine recognize the pattern, and then make the machine smarter by doing things which we assume only humans used to do that or could do that earlier. Now that is what basically is artificial intelligence. So does it depend on machine learning? Definitely. Only when a machine recognizes the person is Rahul or the person is A or the person is B, then you can expose that through a form of an SDK. Okay, where there is an API available for people to invoke that. Okay, so artificial intelligence depends on machine learning. If you look at this diagram, you'll be able to recognize the relation between them. So only because ML exists, AI is existing. Okay, so that's what basically artificial intelligence and machine learning and data science all about in brief. Okay, remember, people study a complete branch of engineering in this field. Okay, or people do this kind of things in a huge course in the form of 1 year or 2 year course called postgraduate diploma and all that stuff. Okay, so I'm just trying to give you one-liners definition of what these things can do. Okay. Now, why are we discussing these things? So the question is, can we do these things in Python? The answer is yes. Okay. Python is one of the predominant language for doing this. Okay. That's the overall gist here. Got it. Yeah. So you use the data for doing some analysis or use the data for doing some visualization and use the data for doing some machine learning. So how is it done? So I'm going to tell you how is it done in Python. OK, what is the popular way of doing that? So if you have decided to use Python, right, there are certain libraries and frameworks that you'll end up using. For example, you use something called NumPy. What is it? It's a linear algebra library for Python developers. So what can you do with it? You can use NumPy for representing data in the form of arrays. OK, irrespective of the dimension, whether it is single dimension, double dimension, 3-dimension, you can use NumPy library for representing arrays, and it also exposes functions for manipulating those arrays. OK, so NumPy is for that purpose. Is it useful in the world of data? Yes, definitely useful, because unless you represent data in the form of array, you'll not be able to study that data, isn't it? So in the world of programming, there is something called vector. What is vector? Certain sequence of data, isn't it? So NumPy is like representing data in the form of array. It's very popular in the world of Python. You'll ask me, if you already know Python, you'll ask me if we have certain built-in features in the Python for representing a vector, then why do we need a NumPy array, isn't it? The reason is very simple. It's all about speed. It's all about performance. OK, so NumPy is much faster than, let's say, a regular Python list. And the difference becomes much more evident when you're working with huge amount of data. OK, so why is NumPy faster? For the simple reason that it has its bindings in C language. That means it internally uses some C code. That means already precompiled code. Got it? And that's the reason why it is much faster. And obviously, when you're working with huge amount of data, naturally performance does matter, isn't it? So that's NumPy, representing data in the form of arrays, irrespective of the dimension. OK, what is the dimension that you need? It all depends on the use case. It all depends on what kind of data you're working with. OK, and then we have something called Pandas, right? Very important for this field of data analysis and machine learning. So what is Pandas? Again, it's a software library written for Python people. Interestingly, Pandas internally uses NumPy. OK, so when you try to install Pandas, it checks whether you have already installed NumPy. If not, it will install NumPy first, and then Pandas will get installed. Why? Because Pandas allows us to do analysis on data which is represented in the form of arrays internally. And that arrays is nothing but NumPy arrays. OK, so it's a library for Python developers for doing data analysis. So what I mean by that? Treat Pandas like an in-memory Excel sheet. You all know what is an Excel sheet, right? Or if I have to make it generic, let's say spreadsheet. Got it? So when we talk about spreadsheet, right, that's a GUI application. Microsoft Excel or LibreOffice or OpenOffice, they give you spreadsheet kind of an application. Now that's a GUI application. What if my data is in memory? What if I want to do analysis of data through my code? Obviously, we need a library which can represent that data for doing analysis, right? Now that is what is Pandas. What does it do? It offers you data structures and functions which can manipulate that data or expose that data which is there in those data structures. So it allows us to majorly work with something called series and data frames. Series means a data in the form of a vector, and data frames is basically tabular data. OK, so where is the data coming from? Well, you can generate that data in the memory for experimental or learning purpose, or if the data is available externally, it can load from that as well, right? It can read data from CSV files, it can read data from Excel files, from JSON files, or if there's a remote API which is sending you HTML table, it can load that table as a data frame, or it can connect to a database and then retrieve data and represent that in the form of tables. Okay, so there are various data sources that Pandas supports. Now, what is more important is not the data source. What will you do after loading that? Okay, through Pandas, what will you do with it, right? Now, what we do is called data analysis. So Pandas is the predominant library used for data analysis. So there's a concept called data frames, okay, which is very, very similar to the concept that we have in R language. R language also uses something called data frames and all that. Okay, so let me tell you, R language, even though it is very popular for doing mathematical and statistical and predictive analysis and all that, right? Nowadays, what I've observed is it's a language which is getting confined only to universities. Okay, it was a language invented by mathematicians and statisticians for doing a specific task, that is in the world of data. Whereas Python is basically a general purpose language. Okay, so I'll show you an interesting statistical site in future where it shows you on certain yardsticks which languages are popular in the industry. Okay, and even though R was very popular once upon a time, now its popularity is slowly falling down. That doesn't mean it's a bad language, or it doesn't mean it is lacking features, but it is simply not able to cut the ice in the world of developer community, where Python is more embraced than other competing languages for doing data analysis and machine learning and all that stuff. Okay, so Pandas is for doing data analysis. Then we have something called matplotlib. So I was talking about in the previous slide, if you remember, I was talking about something called data visualization, right? So if you remember this visualization aspect, data analysis, we use basically NumPy and Pandas, whereas in the visualization aspect, right, you used to understand data by showing it in the visual context. Now that visual context is nothing but matplotlib. Okay, a very interesting Python library for plotting data. Whatever numerical data is available, you want to show that data in the form of charts, graphs and charts and all that. And you can basically use matplotlib for that purpose. Okay, not only it can save the plots and graphs for you, but if you are using it in an environment where you can use it to view it immediately, right? So we can do that. For example, if you are using matplotlib, let's say in a Jupyter notebook environment, you can show the plot then and there itself. Of course, that option of saving is always there, but instead of saving it and then viewing it in an image viewer later, you can see it live in the environment itself. That's the reason why, okay, notebooks are so preferred way of working with data, right? Whoever is the world of data, they basically prefer working with notebooks. So whether it is Jupyter notebooks for Python, or if you're working with, let's say, something like Databricks, okay, there also we have the concept of notebooks, which is very similar to Jupyter notebook concept, where you write the code in the form of cells and then you execute the cells and you see the output there and there itself, and then you go to the next cell. So kind of, modular kind of programming. Of course, in the end, when the job is done and if you feel everything is working, you can export the content of the notebook in the form of a script, and you can run the script whenever you need. Okay, but doing coding and learning through a notebook is one of the preferred way of doing that. Okay, so what are the different types of notebooks available to us? Like we have something called Jupyter Notebook, then we have something called Google Colab. Okay, what is the difference between them? What is the benefit of one over the other? We'll discuss all that as we progress further. But you understood what is matplotlib, right? It's basically Python library for doing data visualization. Then we have something called scikit-learn, the other aspect of working with data, right? I was talking about the third aspect, and that was basically the machine learning, right? So for machine learning, you use certain algorithms. So scikit-learn is that library which has many useful built-in algorithms. Okay, so you have to pick up an algorithm based on the kind of machine learning that you are doing. So when we go in detail, we'll see there is something called supervised learning, unsupervised learning. So based on the purpose, okay, you'll pick up an appropriate algorithm, or maybe sometimes, you'll apply multiple algorithms and try to understand and use the model which is giving you better accuracy, or based on certain, what they say, metrics, you decide which algorithm is giving you better metrics or better performance. We can say in layman terms, is giving you better performance or better predictions, and then you stick to that. So scikit-learn is that library, okay, which has all the built-in algorithms that you can do to use machine learning on your data, make it recognize patterns and generate. Ultimately, what we generate is called an ML model. We generate a model, and that model is what we use for doing predictions or recommendations in future. Or on top of that model, we write a wrapper and expose that wrapper for doing things that we call it as intelligent from the machine perspective. And that is why we say it is artificial intelligence. Why it's called artificial? Because it is not something that it was born with, isn't it? See, for example, if you take the species of humans, right? We are born with intelligence because we have brain which stores data, and then we use that data to do things later, isn't it? We recognize or we take some decisions. So ours is basically natural intelligence, whereas machines are not born intelligent. They are made intelligent. How? By learning things. Now that is where artificial intelligence comes into picture. Okay, so yeah, so scikit-learn is one such library. There are many other libraries based on the purpose. OK, so there is something called TensorFlow. There is something called PyTorch. OK, whenever you want to do something like NLP, right? So there is another aspect of machine learning called deep learning. We are not getting into that in this course, but let me tell you, there is one more detailed disciplinary field, and that is what basically is called deep learning. OK, so it's basically we call it as DL. So when you want to do just machine learning, scikit-learn will be sufficient. But if you want to do deep learning is like trying to simulate, okay, the functionality of a human brain. Like our brain, store data, and then the data flows in the form of something called neurons. And this is how basically we take certain decisions. OK, so we are trying to replicate that in machines. Now that is what is deep learning. And how is it done? By using certain libraries and frameworks. So for that, we have additional frameworks called NumPy, PyTorch and TensorFlow. We have those things for doing deep learning. So there is machine learning, and then there is something called deep learning. OK, NLP and all that stuff, right? So that is where deep learning comes into picture. Now, when you want to apply all these algorithms, obviously we need to write certain code. First, we need to have access to data. Then we need to write some code. So data and the code, when both are on your machine, okay, it's good, no doubt about it. But when you're working with large amount of data, when you want to train, okay, basically recognizing patterns is nothing but training. So when you want to train with large amount of data, and you want to do things quickly, obviously we need huge storage and we need access to huge compute power, isn't it? And obviously sometimes we need access to something called graphics aspect as well. OK, so having a machine, a single developer machine for doing all these aspects sometimes is an overkill. OK, but these things are easily available in the cloud environment, isn't it? So it is getting more and more popular to gather the data and do analysis on the data and apply certain algorithms to generate an ML model from the data. It's getting popular to do these aspects in the cloud. OK, like for example, our applications are deployed in the cloud, whether it is in the virtual machines, that is server, or whether you want to do serverless, or whether you want to store data, whether it is blob data, OK, or what we call it as right, unorganized way of storing data, or whether it is relational databases, whatever you wish to do, everything is nowadays happening in the cloud. So why not do ML in the cloud, right? And that is the reason why you take any modern or top cloud service provider, they will have all the facilities which allow you to work with data and do analysis and machine learning on that data. So if you take Azure, yes, we can do machine learning on Azure. You take AWS, yes, we can do. You take Google, yes, we can do. OK, I'm talking about the top service providers. They give you facilities. Basically, facilities are always in the form of services, right? Cloud is always through service. So there is a VM service, there's a VNet service, there's a storage service, there's a database service. So there is an ML service, machine learning service. Okay, so in Azure ML, that's the machine learning service of Azure. It's a PaaS offering. Those who know cloud, you know what is PaaS, right? There is infrastructure as a service, then there is a platform as a service. So it's a PaaS offering, which allows us to work with data and use that data for doing, okay, predictive analysis and recommendations and all those things. If you want to generate the model, you can use ML, Azure ML, for doing all these aspects. And not only generate the models, you also deploy them. That is what is more important, right? After getting the model, what will you do? You'll use it in real time. So obviously for that, you need to deploy it. So you can deploy it. If it is a small scale activity, you can deploy it in something like Azure Container Instance, ACI. Or if you envision certain heavy workload on it, then you can deploy it in something like AKS, Azure Kubernetes Service. AKS cluster is automatically created and your ML model is deployed in that. And then you can use it for some real-time inferencing or batch inferencing. Real time means you give it some data and get the result immediately, the predictions data immediately. That's called real time inference. Batch inferencing is you upload huge amount of data and the result is available to us for us later, for us to download it later. Okay. For example, I have given data of one patient. I want to immediately know whether that patient is dynamic or diabetic or not. Yeah. So that is called real time inferencing. Imagine I'm giving data of 1,000 patients. Now I want to predict whether they are diabetic or not. Obviously, applying that algorithm or that function on 1,000 patients, right, will obviously take some time. So we'll rely on something called batch inferencing. What will you do? You'll upload the data at some place and then you'll trigger the batch inference. So batch inference will pick up that data and put the results in some file. And whenever, okay, the results are available, we'll pick up the data, the predictions, download that file and look at the predictions. That's called batch inference. Okay, something which need not happen immediately, that's called batch, isn't it? Like for example, in the traditional computing world, batch processing is very popular, isn't it? Something which happens usually, okay, in the olden days, something which used to happen overnight. Like for example, a board has conducted certain examination. Now all the corrections and evaluations have been done. Now we need to publish the results. So usually what they do is they run a job which can take the score of all the students and generate some kind of report and then publish that report and then give it to certain newspaper or make it available on the site or whatever. So all that happens after the batch processing, isn't it? Because imagine a university where thousands have written some exam, right? We can't get the results immediately. So they do batch processing and then overnight some process will happen and then next day morning the results will be available. So student will enter their registration number or hall ticket number and then get the result. But before that, batch processing has been done. So things like this will be available in any kind of cloud environment. So Azure ML is very popular, okay, for doing ML activities in the cloud. I'm not saying others are not so good, but I have found among others Azure ML to be very naive, very easy to pick up and start doing things, especially the feature called Auto ML, right? Where you will provide the data and then it will automatically, okay, create the models based on the data using various algorithms, and it will tell you which algorithm is giving you better accuracy or better metrics. And then you will pick up that particular model and then deploy that model. So lots of interesting things can be done in Azure ML. So in this course, we have decided to do learn ML and then learn how to do ML on Azure. Remember, Azure ML has the knowledge of ML as the prerequisite. So that is why we'll do ML on our local machine first. Then we'll see how to do that on Azure. Okay. Obviously, for that, you need to have access to an Azure account through which you will do machine learning on Azure. Okay, so a bit of familiarity of Azure is required here. Like for example, knowledge of working with Azure and then storage account and all that stuff. Little bit knowledge, fundamental knowledge of Azure. If you are aware of, you'll be able to easily do that. Okay, and then there is a certification also available for that called DP100. That's basically Microsoft Azure certification for data science and ML. Club them together Okay, you have a data scientist and ML kind of certification. You have a similar certification from AWS also. Okay, but in this course, our concentration will be on doing ML on Azure. Okay, that's the interesting aspect. So let's start this wonderful journey of learning with and through Python. Okay, that's what basically this is all about. And then, yep, looking at the chat window. Let me know if you have any questions, guys. Feel free to unmute and ask whatever questions you have. I have already told you about the prerequisites, right? Python fundamentals and Azure fundamentals. These are the prerequisite. I'm going to give you a quick overview of Python. That's a very brief and quick overview of whatever you need to progress further. But in detail, you can go through my Python course and learn Python. OK, there is a break because this is a weekend only batch. I'll tell you when is our next session. So there'll be a break here and use that break to go through Python in case you're not aware of it or you want to quickly revise and recap that. OK, so that is one aspect. Other aspect, a bit of Azure knowledge is needed. OK, so you need to navigate through the Azure portal and do some activities there. So a bit of Azure knowledge is needed. So these are the prerequisites. OK, very bare minimal Azure knowledge. You need not be expert in Azure or you need not be certified in Azure. OK, very bare minimal prerequisite. So that's the thing. So coming to our sessions, we'll be meeting weekends only. India time is Saturday and Sunday morning 7:30. We'll have session at least for 3 hours. OK, so a few minutes here and there based on the topic. So if a topic finishes and if you don't have much time to start a new topic, we will call it a day on that day. OK, or if I can extend the session by 10 minutes and finish the topic, I'll extend by 10 minutes. So at least we'll have around 3 hours of session. And if it is becoming a bit heavy, we can have a break in between as well. OK, I would rather prefer to take a small break so that you guys can freshen up and come back with fresh mind. So that's how the session will go on. So the plan is to have this for 14 weekends. So based on how you guys pick up and based on OK, how we are able to proceed further comfortably. The plan is around 14 weekends. So let's see how things pan out as we proceed further. Yeah, somebody had a question. Please go ahead.
Yes, Rahul. Actually, I'm completely new to this field, so I don't have any knowledge about Python and even Azure. Actually, I'm working in Saudi Arabia from last 10 years, and I've changed my field from computer science to petrochemical industry. So now I'm planning to come back to IT industry. So I was thinking to learn some data analytics and all. So, and as I said, I don't have any Python and Azure knowledge. So what would you suggest me regarding this? If I, as you're saying, you will be covering the overview of Python.
Yeah, we'll have a yeah. Bilal will have a quick recap of what is more important in Python, which will be useful for us further in the course. OK, but if you want to learn Python in the traditional way, how we teach Python as a course, only Python as a course, then we'll give you access to the videos. You can go through that. OK, there's a small break coming up in our course. Unfortunately, there is a death in the family, so I have to visit that place next weekend. OK, so next weekend there's no batch. I mean, there's no class, and our next session will be on. I'm talking about India time. OK, 25th of May. So there's a break of 1 week in between. So you'll get around 2 weeks of break, right? So you can utilize that break to go through that Python videos. We have around 20 hours of course, I guess. So I guess these 2 weeks should be good enough for you to get familiar with Python. OK, Azure.
Regarding Azure.
Yeah, that is something that you need to take care of. If you are in a package of ours where you have access to Azure as well, then probably you can go through the at least certain fundamentals of Azure. It's not compulsory. I'm telling you now also, it's not compulsory. But if you're familiar with Azure, you can recognize things in a better way. Okay. But it's not a showstopper. It's not a showstopper. Okay, because I have seen earlier some people who are not aware of Azure. They are doing machine learning on Azure, and as and when they find time, they learn other aspects of Azure. Okay, that's the concept.
Okay. Thank you. My hearty condolences to you.
Thank you so much. I'm sorry. Yeah, you said condolences. I thought, yeah, that's an unfortunate death, so I have to be there. But anyhow, utilize this break, okay? Somebody's asking in the chat. You have taught AWS. You have taught AWS. Why Azure? Well, the concentration is not about Azure or AWS. The concentration is on getting the things done. That's more important. Okay. See, for example, there was a company who wanted me to get certified for Azure on ML, and then they say you are eligible as a trainer to teach ML on Azure. So obviously I had to learn that on how to do ML on Azure, and then naturally I got certified and entry into that organization, isn't it? So that's how basically things happen. Okay. So, and it's not a new story. It's an age-old story. For example, if you look at this certification, right? That's basically the DP100 certification. We get a certification like this called Azure Data Scientist Associate. Okay, so you can basically see I cleared that long time back, January 2020, right? And I have been renewing that, and it expires in January 2025. So that's basically your DP100 certification. Okay. So it's all about ML on Azure. It's not about Azure. Okay. Of course, my colleague Sandeep does Azure, okay, in detailed way. So if you want to learn Azure, I think that would be the right place. If you want to learn how to do ML on Azure, so this is what that course is concentrating on. Okay. It's not that we cannot do ML on AWS or Google, but that was a prerequisite for me to take certain sessions. So that is why I had to clear that certification. Okay. That's the concept. Yeah, somebody had a question. Please go ahead.
Are we getting access to practice the portal? The portal?
There is an Azure Pass which I get. I guess we are providing it at a very economical cost. So when you buy that Azure cost, you will get access to the Azure portal. When you buy that Azure Pass, right, you get access to that portal. And if you are part of an offering called, I think it's called Platinum membership now, you already have access to the Azure portal. Okay. If you are not yet having access to Azure, or if you are not yet part of any member of ours where Azure access is provided, okay, I'll figure it out and let you know how you'll get access to Azure. Okay.
Okay. One more question. In real time, how like we don't do from portal, right? Are you?
I'm sorry, your voice is breaking. I just heard real time.
Yes. Can you hear me?
Yeah, I can hear you. Go ahead.
Yeah. So how we would be connecting, like from the portal we won't be doing, right, in production or in bigger environment.
We use portal for doing ML model creation, and then we can deploy from within the portal itself. Either you can deploy it there, or you can create a wrapper and then expose that wrapper so that others can utilize it. So when you deploy it in portal, right, when you say real-time inferencing, that's nothing but deploy from the portal itself. So that real-time inferencing requires you to expose certain APIs, and people will use REST API to invoke your ML models. That's real time only, right? Real time inferencing. Yeah. So that's real time. So if you have done ML on Azure, and if you feel you have some models that you can expose directly, Azure has that facility. Or you can take that model and write your own custom API on top of that. Both the options are available.
So it's
up to us. How do you want to use the model which has been created?
Are you going to teach that topics too?
Yeah, deploying a model to do real-time inferencing. Yes, that's part of Azure ML.
Okay, thank you.
Come on, guys, whatever questions you have in your mind.
Sir, actually, I have a doubt. I'm a beginner of Azure, and I'm doing Azure AZ900 certification right now. So, is that enough, or DP100 is also suggestible for this course?
DP100 is what we'll be learning.
Okay.
For which little bit of Azure knowledge is needed. That you are anyhow learning, isn't it?
Yes, yes.
Yeah. Yeah, course content is already shared with my colleague Shubham. He is there in this meeting. Okay, he'll be sharing with you guys. Just drop in your contact details or whatever WhatsApp group you are in. Shubham will be there in that group. Okay, you contact him and he'll be sharing the course content with you. Anyhow, we are going to come up with a dedicated page for this course on our learning portal. You know what is our learning portal, right? Most of you are aware of that. If not, let me quickly show you here. That's basically our learning portal. It's called best.nettraining.com. Okay. So in this learning portal, a new course is going to come up. That's called machine learning. Right. And in that course, you will get access to the course content. I mean, you will see a document which gives you course content. Okay. Got it. So you will see a new course coming up here. We already have courses on AZ900, I mean AI 900, AI 102. So similarly, ML course will also come up here, or it will be there in general list of courses as well. Okay. Right. So, or if you want to immediately get it, Shubham can provide it to you. I have already shared with him. He's there in this meeting. Okay.
Do you prefer us to have AI 900 as a prereq?
No, not needed. If you are already certified, that's fine. But I'm not putting that as a prerequisite. Okay. The only prerequisite is Python knowledge. That's it. Python programming language knowledge and a bit of Azure. That's it. These are the only two prerequisites. And you should be good at maths and stats, a bit of maths and stats. OK, a mathematically inclined mind will be able to understand data in a better way.
Okay,
So a bit of mathematics, and if you know statistics, that will be good enough.
Math means how much I should be having, or
School level
minimal.
mathematics. School level mathematics. That's it.
School level. Do you have certain concepts that we should be knowing of?
I mean, you should be able to basically understand the operations that we do on the data, right? For example, we talk about things like the sum, the min, the max, right? The median and all these things. If you're aware of the school level things, that is good enough.
Okay.
Yeah. Okay.
Yeah. Not like we should be like linear algebra, all those things.
No, nothing of that sort.
Yeah, that is what my concern. I'm not. Yeah. Okay. Thank you.
Thank you.
So Rahul, so today's session, like the topics are over, right? And the next session will be from 25th, isn't it?
Yes. Yeah. I was about to announce that the next session will be on 25th May, same morning 7:30. We are meeting India time 7:30 a.m. Okay. IST.
Okay. And those people who are already on a gold membership, they can just visit the page to get the links.
Yeah, that's it. Gold member people will log in into the portal and get the link to attend the session. That's same thing. There's no difference there. Okay.
I have a.
I mean, when you say gold, gold has now become platinum, by the way. Okay. So all gold members are automatically migrated to platinum. Now onwards, those who enroll for gold, the story is different for them. Okay, because gold members do not have access to live sessions anymore. Only platinum members have access to live sessions. Gold members can only watch the recordings. But if you are an existing gold, you are already migrated to platinum. So obviously you get access to the live courses since you're already gold. Okay. The new gold membership now onwards is slightly different. Hope that helps, Sambit.
Yes.
Yeah.
So Rahul, even down the line, once we renew the gold membership, once it is expired, like currently I've been like having this subscription since last 4 years, and recently I renewed it in last December. That means my current subscription is active until December 2024, which is
Right.
already been converted to platinum. That means after
Yeah.
2024, if I have to renew it again, will that be
Yeah, you have to
automatically
renew the platinum membership. So if you go
Okay.
to our portal and if you go to packages, right, you'll
Right.
come on this page. Okay, packages, then gold platinum is there, right? So
Right.
if you scroll down, you'll see the differences between these two courses, gold and platinum membership. Okay, because you're already platinum, and if you want to renew your platinum, okay, or do you want to convert into gold, it's your choice. But right now you are platinum. Existing gold are automatically platinum.
Right.
Okay, hope that helps.
Thanks.
Yeah.
If you are not members, we will not get the recording.
You will get the recording, but only of this course.
Yeah, this course we'll get the recording. For how
Obviously,
long we'll get?
yeah.
For how
We'll
long
get it
we'll get the recording?
usually for 6 months.
Okay, thank you.
Yeah. When you enroll for a course, you get recording only for that course. Okay, if you are part of some package, you'll get access to all the courses which are part of that package. Okay, there are so many packages available.
Okay.
Right.
Okay.
The ultimate package only for accessing video is gold.
Mm-hmm.
Videos plus live sessions, that's called platinum membership.
Okay.
Okay. So for gold and platinum membership is valid for 1 year, and you get unrestricted access to all the videos for gold and videos plus live sessions in platinum. I mean, this page will give you in a tabular way all the differences that are there between gold and platinum. Okay. Earlier it was only gold. Now gold has been converted to platinum. So obviously all gold members, we have promoted them as platinum members.
Okay.
But that is only for till their membership is active. Beyond that, they have to renew as platinum. Yeah, go ahead.
Okay, one more question I have regarding the payment. Who should I approach for the payment if I want some?
Yeah. Are you part of any of our WhatsApp group?
I don't.
No problem. Yeah. Can you see the chat window of this meeting?
Yes.
You see certain numbers are mentioned there by Shubham.
Okay.
You can contact Shubham and he will help you in enrolling.
Okay, thank you.
Yeah. So Parmesh, yeah, I'm planning the session for 3 hours. So minimum it will go till 10:30. Okay. Sometimes few minutes here and there. Okay. 10:40, 10:45 based on the topic. But because in US it will become a bit late if you stretch it further. So I'm planning to wind it up by 10:30 only. And 10:30 in the Eastern time will be again what? 1 a.m. I guess. And then people again have Azure session in the evening or something like that. So yeah, we'll wind up by 10:30. Okay. 7:30 to 10:30 India time, Saturday and Sunday morning. That's the plan. Okay, hope that helps. Any other question for me? Oh, by the way, in case you want to get in touch with me in future, I'm putting my number in the chat window. I'm also putting my email ID in the chat window. Okay, in case you want to get in touch through email. Both my voice and WhatsApp number are same. You can see them in the chat, and my email ID is also there in the chat now. And if you are part of any WhatsApp group, I'm there in that group as well. So if you prefer messaging me on WhatsApp, I'm okay with that. Whatever doubt clarification you have. So guys, if you have enrolled, just inform either Kashmira madam or Shubham to give you access to Python videos so that before the next session, you will revise Python and come back. Okay, the next session will be on May 25th morning, 7:30 a.m. Okay. Yeah, before that, you go through Python videos. Any other question for me before you start dropping off?
Sir, in AI 900, one of the fundamentals it was discussed like there are different models like a regression model, and one model is for Boolean and one model is for classification. Kind of categories are there. So are we going to discuss them as part of this course as well?
As part of ML, these are discussed in detail. In AI, in AI, they just give you a high level overview. Okay.
Okay.
In ML, these things will be dealt in detail.
Okay. Okay. So thank you.
Thank you. That's too early for you, I guess, Vinay. Or is it late
No.
night?
No, sir. I came back from UK. I'm operating in India timing zone.
Oh wow. Nice to hear our voice again.
Yeah. Glad to see that your voice also recovered, sir. I'm very happy.
Yeah, I've recovered a lot. Yeah, it's not 100% recovery, but there is the path of recovery has started.
Okay.
So those who don't know what's being discussing, let me tell you, I suffered a kind of facial paralysis a few months back. And yeah, I was completely devastated, not able to talk properly.